Good afternoon, everyone, and welcome to Wausau Distance Education. This is MBF3C, Foundations for College Mathematics, grade 11, and my name is Marvin. We are into lesson number 11 of unit number 3. We started trigonometry last week, and we'll pick up from there. So we looked at, let me just scroll back up and I can show you. We looked at sine, cosine, and tangent. And we looked at what or how to or what formulas we use when dealing with those three sig ratios. And we use the acronym SOHCAHTOA. So SOH is sine is equal to the opposite side over the hypotenuse. And we're talking about the length of the opposite side over the length of the hypotenuse. Cosine is length of the adjacent side over the hypotenuse. And tangent is the ratio of the opposite side over the adjacent. Now, these are ratios. So, for example, if I were to take this triangle and I were to enlarge it, make it twice as big, then the angles, the length of all of the sides would increase, but the angles would remain the same. So, for example, if we had 30 degrees, 60 degrees, 90 degrees, and remember in a triangle, all three angles add up to 180 degrees. So 30, 60, 90. So if we make it bigger, the angles will still be 30, 60, and 90. But the length of the sides will be different. But if you take the ratios and when you do the division, you get the same number. Okay, so we'll look at some examples of how that works a little bit later. So SOHCAHTOA, sine, cosine, tangent. Those are the three trig ratios. There are three others that we don't do in this course, and they're called secant, cosecant, and cotangent, which are basically the inverse of these. You take this one and flip it over, hypotenuse over opposite, and you get secant, and so on. So you really don't need to know the other three, because if you know these three, you can solve any triangle. Now, uh, again, we looked at Pythagoras before this. So Pythagoras, or the Pythagorean theorem, can be used to solve for the length of a side of a right triangle if we know the length of two of the other sides. So if you know two sides, you can solve for the third side using the formula c squared equals a squared plus b squared. Trigonometry is handy in that we don't need to know two sides. Now, if we know two sides, then I can calculate the measures of all the angles too. But we're trigonometry, we're going to be dealing with angles and sides, not just sides like we did in Pythagoras. So there's the difference. If you know an angle and one of the sides, okay, in addition to the right angle. So if we know this angle of that side, then we can solve for the other missing parts of the triangle. So we can find the missing angle and we can find the length of the other two missing sides that we don't know. So, and it comes in handy when we have to solve problems, for example, height of a pole. If you want to find the height of the pole and the pole is, say, 60, 70 feet tall, but you can't climb to measure it, then it's nice to have a way to solve that problem without having to climb the pole. And that's where trigonometry comes in. So we can take a measuring tape, measure from the base of the pole back a distance, so the adjacent side, the flat part of this triangle right here on the ground. If we know all that, and then we can use a protractor or some other device to determine the angle. So you're just using a sight line from A to B. You can determine the angle at A. So once you know that angle at A and you know the adjacent side, then we can use trigonometry to find the opposite side, which would be the height of the pole, and hypotenuse might be the guy wire. So guy wire is a wire that sometimes you will see attached to the top of a pole to the ground, has extra support to help it stay in place. Okay, so there is a review of sine, cosine, and tan. Last week we started on this particular problem right here. Uh, So what we're going to do today is we're going to continue working on that particular problem. And for some reason, yeah, what you're seeing is what I'm seeing. Okay. Um, what we need to do is just label the parts of the triangle. And we did it last week, but we're going to do it again today. Let's see here. What you're, okay. You are sharing, I'm looking at my screen and hopefully you're seeing all of this. Okay. So the angle that you're given here is the reference angle. And we call it a reference angle because we have to label a triangle based on one of the two angles, that angle or this angle. Doesn't matter which one we use. So if we use the angle that we're given, which is 70 degrees, then that becomes the reference angle. So now what I need to do is I need to label the parts. So opposite of the right angle, this part, this one right here, opposite the right angle is the hypotenuse. H, and we just use three letters, hypotenuse. The side opposite, so this is 70 degrees, opposite of that angle is the opposite side. And the other side, there's only one side left, and that would be the adjacent side. And as I said last week, the adjacent side and the hypotenuse, so here, so the adjacent side and the hypotenuse make up the reference angle. Okay, so keep that in mind. So last week we did work through the first part and we labeled it X. It was already labeled X. There's X right here. That's the hypotenuse. And we said that that was 7.7. Oops, 7.7. So we did that last week. The angle C, so remember that the three angles in the triangle add up to 180 degrees. So if I take 180, subtract this one, which is 90, subtract that one, which is 70 degrees. So 180 minus 90 minus 70 is 20. So the measure of this angle here, right in here, why am I, let's erase that for now. And let's go into draw. So this angle right here is going to, why is it not? Let me draw it out. Small. That is 20 degrees. So you want to double check, make sure that they all add up to 180 degrees. 90 plus 70 is 160 plus 20 is 180 degrees. So now we just have to find y. So y is right there. That's the part we have to find. So always work with what you're given. So we were given the angle of 70 degrees. We're given the opposite side, okay, with 7.2, and we have to solve for the adjacent side, which is y. So opposite and adjacent would be, come up to here, opposite over adjacent is tangent. So we're going to be working with tan. So I'll come down here. So tan of A, always write the formula down first, is opposite over adjacent. Let's do the substitution. Let's scroll back up and you'll see here that the angle itself is 70 degrees and the opposite side is 7.2. So tan of 70 equals 7.2 over the adjacent side is y, which is what we have to find. And then we make this over 1, so tan of 70 over 1, and anything divided by 1 is itself. So we're not changing anything. We're just making a proportion so we can cross multiply. So the tan of 70 times y will be y times the tan of 70. And 1 times 7.2 is 7.2. And then we simply divide each side of the equation by what's in front of the y, which is, this case is tan of 70. So divide that side by tan of 70. What if you do on the left-hand side, you must do on the right-hand side too. So divide that by the tan of 70. So you're just going to take your calculator now, and you are going to go 7.2 divided by, press the tan key, and then 70, and press equals, and you'll get 2.620585687. So round that to the nearest tenth or one decimal place, you'll get 12 point or 2.6. So up here, that is 2.6. So now we know that this side is 2.6. The hypotenuse is 7.7, and that angle is, so we know all of the angles. We know this one's 20, 70, 90, and we know 2.6, 7.2, and 7.7. Always double check. Hypotenuse has to be the longest side, which it is, 7.7. Okay. And if you add these two numbers together, they have to be bigger than 7.7. So 7.2 and 2.6 is 9.8, which is larger than 7.7. So we're quite confident that what we have done here is indeed probably the right answers. Okay, so what I'm going to do now is I just want to get rid of some of these marks now, oops, because we don't need them anymore. And I just want to get rid of them so that if, oops, uh, so that if I have to send this up north to someone, oops, and let's go to the undo button there, so that it doesn't look messy. Okay, so I just do this on air with you so you can see what I'm doing each step of the way. So we've done that now. So we'll just get rid of all of the marks, but make it nice and tidy again. So that is, in a nutshell, how you would solve an equation, or sorry, oops, undo that again. That's how you would solve a triangle. So in other words, find all the missing parts in the triangle. So that is one example. So let's look at another one. So this one here, this was number one, and we're going to, I'm just going to pull this back up here now so you can see it a little bit closer. So let's solve for one more. Let's do number two in the up here. So we've done number one. Now let's do number two. So again, the first thing we have to do is look at what we are given. So we're given this angle right here, right there. Okay. That angle is 16 degrees. So this angle here, that's my reference angle. That's the angle I'm going to use to solve for the other two sides, or the length of the other two sides. So opposite of the angle itself, so this case y, that's the adjacent, sorry, that's the opposite side. Oh, let me just make that. So this is the opposite side. This is probably the most important part because if you can label all the parts, the rest of it is fairly straightforward. We're going to follow the same procedure every time. Each and every time you see this, do the same thing and you'll be okay. Opposite the right angle is the hypotenuse. And remember that the other two sides don't have special names, they're just called legs. But in trigonometry, we're going to call them opposite, hypotenuse, and the third side is the adjacent side. And again, adjacent means next to or part of. So this is the angle right here. So the hypotenuse, this is the hypotenuse right here. And this is the adjacent side right here. So the hypotenuse and the adjacent side make up the angle. The other side is the opposite side. Again, hypotenuse is the longest side. So we have the hypotenuse, we have to solve for the adjacent side and the opposite side. Doesn't matter which one you do first. So let's scroll down and see which one I did first, actually. So in number two, I did uh, opposite over hypotenuse. So if you're not quite sure, come back up here. Opposite over hypotenuse is sine. So I'm going to be using sine opposite. So sine of 16 degrees equals opposite over hypotenuse. Hypotenuse is 20 and the angle is 16 degrees. So down here, write the form, and again, the angle itself is Q. So we're going to say the sine of Q is equal to opposite over hypotenuse. So again, formula always comes first. Now due to substitutions, so we have sine of the angle itself was 16 degrees, make it over 1, so it's a proportion, equals opposite is y over hypotenuse is 20. So now I've done the substitutions. So now it's going to be cross multiply. Okay, 1 times y is y. And then sine of 16 times 20, or 20 times sine of 16. I'll put the number first so it doesn't get confusing. So 20 times the sine of 16. Multiplication, it doesn't matter the order. So 2 times 3, 3 times 2, you'll get 6 each way. So 20 times the sine of 16 or sine of 16 times 20, you'll get the same answer. But you typically put the number first. So now there's no division here now. Now it's simply a matter of taking your calculator and going 20 times sine of 16. So 20, oops, turn it on first. 20 times the sine of 16 is equal to 5.512747116. So round that to the nearest tenth and one decimal place, you'll get 5.5. The angle P, which is the angle that we don't know, which we weren't asked to find it. So what did we found y was 5.5. So y is 5.5. So 5.5. Now, we can use Pythagoras if we want to do that to solve for x, but we're going to use trigonometry. The angle. Oops, sorry, I didn't go back up far enough. Sorry, let's go there. So I'm going to get rid of my mistake. So let's get back in here. So we said that y was, sorry, y is right here, 5.5 or 5.5. This one is, so the opposite, 5.5, hypotenuse is 20. So now we have to solve for the adjacent side. So the adjacent side and the hypotenuse, adjacent and hypotenuse, come back up here. Adjacent over hypotenuse is cosine. So now we're going to be using cosine. So we come down here. So cosine is adjacent over hypotenuse. Cosine of 16 over 1 equals x over 20. Cross multiply, 1 times x is x. 20 times the cosine of 16 is 20 cosine of 16. plug that into your calculator. 20 cosine 16 equals 19.22523392. Round that to the nearest tenth or one decimal place, and you'll get 19.2. There's the angle we said was subtract 74 degrees. So we go 180 minus 16 minus 90, you'll get 74 degrees. And we said that x in this case was 19.2. X is 19.2, sorry. So, and again, so what we can do, so hypotenuse, got to be along the side. That one is 20. This one is 19.2. That one's 5.5. So A, it is the longest one. So that's good. And these two added together, 19.2 and 5.5 would be 24.7, which is bigger than 20. So then chances are those two are right. So we should be good. So let's tidy this up again now for the crew that, if I send this up. So now we have solved two problems, and you've seen where I've used sine, cosine, tangent. So I've done an example of each of those now. So let's just work. And you saw examples where you had to cross multiply and divide. And sometimes, so down here, we get to cross multiply then divide. And these right here, we just had to cross multiply, and then we end up with the answer. So let's tidy this up down here as well. So you've seen examples of sine, cosine, and tangent, and you've seen examples where you have to cross multiply, then divide, and examples where you simply just had to cross multiply depending on the problem we were dealing with. Okay, so you've pretty much seen examples of all of the different types of problems that you can get when dealing with trigonometry and sine, cosine, and tangent. There are going to be other things that you might have to do. So we've done number one, and today we've done number two. So let's do one now where you have to find the measure of an angle. So all the ones up above, these examples, all of these up here, and these can all be done the same way. I'm going to leave the rest for you. You want some extra practice? And I would just do them for practice. I just love doing this stuff. So, but I don't want to do them all online because it's just going to take too much time to do all of them online. So we'll keep that in mind. So now in these, we were all given an angle. And you knew at least one angle, sometimes two. Okay. So as long as you know an angle and a side, you can do what we did with sine, cosine, and tan. Now, what about in cases where now you know two of the sides? Now I can use Pythagoras to solve for the third one. Okay. Uh, let me just, I can use Pythagoras to solve for the third side. Easy enough. But I can't use Pythagoras to find any of the angles. Okay. So first thing first is you have to pick an angle. So we're going to do X first. So this is going to be my reference angle. So I'm going to use that for my reference angle. What am I given? I'm given, this is the angle I'm dealing with first. I'm going to solve for X first. Okay. I'm giving the opposite side, and I'm given the adjacent side. Okay. I don't know the hypotenuse. Okay, I don't know what this one is. That's the hypotenuse. We're going to solve that using geometry, not trigonometry. But we could have used trigonometry too. And I might even do it for you. We'll see how we're doing for time here. So, opposite, adjacent. And again, if you need to double check, just go back up. Opposite and adjacent right here is tangent. So we're going to be using tan. So the first part is to write down the formula. Tan of x equals opposite over adjacent. Then we're going to do the substitutions. The opposite side is 4 and the adjacent side is 6. So we have 4 divided by 6. So now to find tangent. So when we're finding the angle, we have to do we use what we call the inverse tangent. Okay, which means we have to use tan to the negative 1, which means inverse tangent. So on your calculator, you might have to press the second function button, second function tan, and then, okay, you should turn it on first. Second function tan, second function tan, finally got it. 4 divided by 6, close the bracket, and I'll get 33.69. Round that to the nearest degree, works out to be 34 degrees. Now so this is going to be 34 degrees. Now, if I'm going to use y now I got to relabel the triangle. Because y, if this is my reference angle, then this would be the opposite side, and this would be the adjacent side. So we have to relabel. So that's why it's sometimes a good idea to use a pencil. So now we're going to relabel it using using y as the reference angle. So now this would be the opposite side, and this is the adjacent side. So it all depends on which angle we're working with. So tan is opposite over adjacent. So tan of y is opposite is 6 over adjacent is 4. So now you're going to go tan to the negative 1 again. So our second function, tan or inverse tan, 6 divided by 4. Close it, press equals. I'll get 56.3 or about 56 degrees. So 34, 56. So this angle is 56 degrees. Now, we didn't have to do this part here. Okay? We could have taken a shortcut. The shortcut would be right here. I could say that angle y is equal to 180. Because if you know two of the angles, you can subtract those two. So 180 minus, that angle is 90 degrees, minus this one here, which is 34. So angle y is equal to, take your calculator, 180 minus 90 minus 34, and you'll get 56 degrees, which is exactly what we got using trigonometry. Okay, so, you solve for one. If you want practice using your tangent, then by all means do it this way. Then to solve for the third side, we can use Pythagoras. So c squared equals a squared plus b squared. The two legs are 6 and 4. So it will be a and b, doesn't matter which is which. So 6 squared plus 4 squared. 6 squared is 36 plus 4 squared. 4 times 4 is 16. 36 plus 16 is 52. So to solve for c squared, I need to take the square root of c squared to get c is equal to the square root of 52. Put that into your calculator. So if I go square root, square root of 52, I get 7.211102551. Round that to the nearest tenth or one decimal place, you'll get 7.2. So the hypotenuse is 7.2. So x, we said, was 34 degrees. Y was 56 degrees. Okay. So now we've done one example. Let's try one more. So this one we had to use tan, and we can use tan for both of them. So now the next one we're going to use, sorry, one where we don't have to use, I'm not going to be using tan. I'm just going to make sure my screen is okay. That's fine. So let's look at this one here. Oops. I don't know why it's, oops. Okay, there we go. Get back into here, making sure you're seeing what I'm seeing. Okay. We have to figure out which one of these we're going to solve for first, X or Y. I usually pick whichever one comes first in the alphabet, so X. So there's my reference angle, X. Okay, so that's what I'm using for my reference angle. So I have to label the parts uh, that are given. So this is the side opposite the right angle. So that's the hypotenuse. And I'm given this side right here, which is the adjacent side. So adjacent over hypotenuse, if you scroll back up, you'll see it is indeed cosine. So the cosine of angle X is equal to the adjacent side over the hypotenuse. So I want to get out of here so that I can get out of there. There we go. So due to substitutions, the adjacent side is 7, and the hypotenuse is 14. So 7 over 14. So cosine again. So now I'm going to go second function cosine 7 divided by 14. And press the equal sign, and you'll get 60 degrees exactly. So x is 6 degrees. So now again we can do this part over here. So angle y is equal to 180 minus 90 minus the angle we just found, minus 60. So angle y is equal to 30 degrees. So again, that's using geometry or yeah, just subtracting the two angles you're given from 180. Now, so we've got this one. So if I want to do y, then I have to relabel because now hypotenuse is going to be the same, but now y, this is going to be, I'm looking at y, the opposite side. Opposite an hypotenuse is sine. Now due to substitutions, sine of y equals 7 divided by 14. So the inverse sine of y, so second function sine 7 divided by 14 is equal to 30, which is exactly what we did here. So either way, you'll get the right answer. This might be a little bit quicker. This gives you practice using your trig ratios. So now we have the two sides. So I know the hypotenuse, which is C, and then I have to solve for A or B. So C squared equals A squared plus B squared. A squared, because we're talking about one of the shorter sides now, is going to be C squared minus B squared due to substitution. So C is 14 and B or A is 7. So 14 squared minus 7 squared. 14 squared, 14 times 14 is 196, minus 7 squared is 49. 196 minus 49 is 147. To solve for A, now take the square root of that, and you'll get A equals the square root of 147. So if you do that, second function on the square root of 147, you get 12.124355565. Round that to the nearest tenth or one decimal place, and you'll get 12.1. So let's get rid of, again, those marks now. So now that's how we go about solving for the angles. If you have to find the angle of a triangle, given, so if you got to find the angle, you need to know at least two sides. So length of two of the sides, and you can solve for the angles, and you can solve for the third side by using Pythagoras. You don't have to use trigonometry. So that's pretty much everything you need to know about. I'm looking a bit quicker. Wow. Everything you need to know about solving for a triangle or solving a triangle. So when I say solve a triangle, I simply mean find all of the missing parts. What's missing, find all of it. So find the missing sides, missing angles. Now, when we use geometry, we couldn't find the missing angles unless we knew at least two of them. You could solve for the third one. But if you didn't know any of the angles, then using geometry, you can't solve for the other two angles. Okay. But using trigonometry, you sure can. Okay. So why does that not want to disappear? Okay. I just want to make sure I've got nothing left up there. That is going to make it look messy. So we've solved the triangle, and I think now that you've seen enough that you can solve the rest of these that are listed here, and you can do, actually we've done both of those now. So now let's look at a word problem. So you've seen lots of, or have had lots of practice. So let's do a problem where, let's get rid of that. Oops, get back in here. Oops, what happened? I lost my my window for a second here. Let's see what happened here. This is strange. Let's get in here. Oh, okay, there we go. We're back. So let's delete that. Okay, so now sample problem 11.3 says from the top of a lighthouse that sits 105 meters above the sea, the angle of depression of a boat is 19 degrees. How far from the boat is the top of the lighthouse. So we got to find this distance from here to here. What do we know? We know that from the top of a lighthouse that is 105 meters above the sea. So this part right here is going to be 105 meters. Okay, from here to there. The angle of depression, which is this angle right here, is 19 degrees. Now, if you were looking from the boat up towards the top of the lighthouse, that would be the angle of elevation. And these two angles are equal. That angle here and this angle here are both going to be 19 degrees. Okay. And what we have to figure out is the how far from the boat is the top of the lighthouse. So for this distance down right here. That's what we need to find out. So if we know this angle here, that's my reference angle. So using your reference angle, 19 degrees, label the parts that you know. So opposite here, that's my opposite side. And I'm asked to find, this is what I need to find. I need to find the adjacent side. So opposite and adjacent, if you forget, come back up here. Opposite and adjacent is tangent. So come down here, back down. So it might not be a bad idea just to take a copy of what I just showed you. Actually, so opposite, that's not the adjacent side. I made a mistake. Let's fix that mistake. This is the side opposite, opposite the right angle. Right angle is the hypotenuse. Okay, so we're dealing with opposite and hypotenuse. So come back up, opposite and hypotenuse. So you can see opposite and hypotenuse is sine. So it's always a good idea to double check and have a copy of that for your quick reference. Opposite hypotenuse. So let's do that. So let's get out of here. And I want to insert, and I'm going to go right here, make sure I'm inserting an equation, and go home and put it on the left-hand side. So we are going to be using opposite and hypotenuse, which would be sine. So we've used sine before, so let's come up here and grab it. There we go. I'm going to make a copy of that formula because I'm going to use using the same formula. And I'm going to come in here and I'm going to click on paste. And now I'm going to, so actually, and that's going to be sine of angle. This right here is B. So I'm going to call this sine of, and it's uppercase B. Opposite over hypotenuse. So now it's simply, we've got the formula. The next part is to do the substitutions. So let's do that. So the sine of B, the angle itself is 19 degrees. So sine of 19 equals, the opposite side is 105. So come into here, 05. And the hypotenuse, let's call that C. Because we usually label the parts A, B, and then let's draw in there. So this would be, let's call it C. That's where the C comes from here. So now we are going to make this, come back up here. We're going to make it over 1. So what I'm going to do is get out here. I'm going to make a copy of this. And again, we follow the exact same steps each and every time. Come into here and do my oops. Let's do undo there. So now we have the sine of 19 and I'm going to cross multiply. Okay, and then I'm going to make this. So it's going to be sine of 19 over 1 equals 105. Oops. Keep doing that. Equals 105 over C. I'm going to make that size, I'm going to size it a bit differently so that it looks the same as the others. Okay. Now we're going to cross multiply. So C times the sine of 19. Okay, so come into here. Oops. Let's make a copy of that. And let's do paste. So this is going to be C19. Oops. And let's do C sine 19 when we cross multiply equals, that's just going to be 105. So now the next part is to divide each side of the equation by this sine of 19. So here, make a copy of that. And we're going to paste it in there. And we're going to make this oops. Make that a fraction. So where is my equation? Over here. Make it a fraction. So we're going to divide by sine of 19. And then we have to divide that side also by the sine of 19. Press enter. And I should actually make that a little bit of space in there so there. So now C, oops. So when we do the division now, we'll get C, oops. And make that go on the left again. This is behaving poorly. So C equals, oops, I'm going to have to insert a formula, I guess. An equation. We're going to make it. But let's just do it this way. Make a copy of that. And then paste it down here. So C is equal to 105 divided by the sine of 19. Let's do that. 105. 105 divided by sine of 19. And you'll get, it's going to check the time here now. Let's do that again. So 105 divided by the sine of 19, close up, and you get 322.5. So, and then I'm going to put units back in. So we are running out of time. So what we should write down now is the boat. You can make a copy of that. So now answer the question. And I'll use the question. So the boat is 322.5 meters from the top of the lighthouse. Because it's a word problem asking a question, we should always state the answer. And there we go. So now we have finished that problem, and it works out just right because we've completed another lesson and we could pick up from there tomorrow. So thank you for participating, and I look forward to talking to you again tomorrow. Bye for now. And let's get in.